All right, thank you very much, Ale, and thank you all for joining us today. It's awesome to be part of the Augmented Training Congress. I personally believe that training is probably one of the biggest sectors for AR, and I loved what Seabury has been doing since I first saw them about 5 years ago. I really, really wish I could be there with you in person, but we're still trying to perfect the teleportation technology. Still have some bugs that we need to fix. My name is Orion Bar. I'm the founder of Super Ventures and of Augmented World Expo. And today, Alejandro initially asked me to give an overview of the state of the AR industry, but I thought that you can probably get it anywhere. So instead, I'd like to talk about something that is taking the AR world by storm and promises to make AR go mainstream. And I'm not talking about AR Kit or AR Core, which are great things. I'm talking about something that I call the AR Cloud. Now, the concept is not new, but it feels in the past few months that it seems attainable, with a few companies demonstrating, maybe for the first time, how this concept could actually work in reality. So today I'll cover what is the AR Cloud, why we need it, who can build it, what impact it's going to have, and when to expect it. I think it will be clear how this could also impact the augmented training in a very big way. So now I'm going to the next slide, about 27, no, actually go back one. So 2017 was an amazing year for AR. It went mainstream, but that is only if you are a developer that now has tools to develop with. So next slide kind of lists some of the challenges that AR developers had in the past. First, it was just a hard thing to develop. It was really hard to distribute. And in reality, there wasn't a lot of demand. But all that changed in 2017. Next slide. And one more. With the introduction of some fantastic AR SDKs by Apple, Google, Facebook, Snapchat, now there are some amazing tools to easily build AR applications, which just work. Next slide. And there's no more struggle to find a market of devices that can run these apps. By the end of this year, we expect more than 1 billion devices to be fully optimized to run these AR apps. Next slide. And the interest in AR is now at an all-time high. If you look at this Google Trends chart, next slide, please. Oh, sorry, no. I have a little delay here. So the Google Trends slide shows that it's really at an all-time high. So most people have heard about it, but they're not exactly sure what it's good for. And they're curious to learn more, which is great. Next slide is kind of really asking the question. So if you have this AR kit and all these tools, how come these apps are still struggling to break through the novelty phase? Why is that? If you go to the next slide, I think it's really because the apps that you build today with tools like ARKit and ARCore are like surfing the web with no friends. If you guys remember how the web looked and felt in 1996, it was very lonely, and that's how some of these AR apps feel today. So next slide is really the big question of what will drive mass adoption of AR. You could say that training would be one of those things, and that's perhaps true, but there's still a need for a fundamental AR technology to make it even more ubiquitous. Next slide. Oh, I think, no, one back, sorry. So if you look at the top internet properties out there and you try to see what's really in common across all of these, It's really always about sharing, communication, and collaboration. So if you go to the next slide, to hit the mainstream, AR experiences will need to enable these things. And for that, it has to persist in the real world across space, time, and devices. So what does that mean? Stay on the previous slide, please. What does that mean? It means that I can create an AR experience in a physical space today and come back tomorrow and it will still be there and I will be able to interact with it. And another user can experience and collaborate with it on a different device. And of course, other people can do the same in other places. And to enable these kind of experiences, you need, next slide, the AR cloud. So now go to the next slide, which is what some people call a real-time spatial map of the world, or next slide, when the world itself becomes a screen, a shared spatial screen. Next slide. Some people in the IoT camp like to call it the digital twin, which mimics the world, or as the next slide calls it, when the world has a soft copy of itself. But I think maybe one day we will simply call it, like in the next slide, just reality. So in the next slide, I'm looking at how to figure out how important is this thing. So let's hype it a little bit. At some point in the future, the AR cloud will be the most important software infrastructure in computing. There, I've said it. And why does every AR insider think so? It's because, next slide, the operating system, this could be the operating system of the next era of spatial computing. Everything will run off of it. So it looks pretty important, but the next slide asks the question, but what is it really good for? I mean, we know technology by itself doesn't really solve any problem. So I think if you look at the next slide, it's really, at the heart of it is really the ability to share and collaborate in AR experiences across many users. And the next slide basically argues that the sharing that we see today, whether it's sharing an image or a face filter, or even a video with some special AR effects, like what you can do with the Snapchat word lens tool. If you share it on YouTube, no matter how cool it may be or maybe how disturbing, it's still not the same as sharing the actual AR experience and allowing people to participate in your experiences. So next slide is saying, why is AR sharing really so important? So let's try to understand that. Next slide is kind of a realization I have after being for 10 years in the AR industry and finally understanding, I think, its true meaning. It's really a new way to organize the world information. In the web era, the mission statement that defined it and made Google the most successful and powerful company on the internet was to organize the world's information and make it accessible. And in the next slide, 20 years later, in the spatial computing era, we need information in the now. Ask any millennial and they'll confirm that we need the info for what's in front of us right now, about this restaurant, about that person, or about this object. And we're sick of searching it the old way. The next slide is really about the idea that the AR cloud will allow us to organize information at its origin, on the thing itself. Or in the next slide, as we call it, in situ. So that the how to use of any object, or next slide, the history of any place, Next slide, please. Or even to learn about the background of any person, as in this slide. And the difference is that all the information can be found right there on the thing itself, at its origin, or as the scientists like to call it, in situ. Next slide. And the beauty of it is that every person that interacts with these things, places, or people, adds their own knowledge to it. And next slide is really kind of thinking about how this could affect or help perfect training, which is really our main topic today. So imagine now that you can have training on the job in real time, training in situ, which means you can train on the machine or object or thing that you're trying to learn about. And every experience of a person with that in that training process can accumulate the experiences and make the training even more efficient. So I think still on the previous slide, I think that the purpose of AR, or the promise of AR, could be rephrased as to accumulate humanity's knowledge and make it accessible, not a click away, but at a glance. And of course, there are many open questions about how to do this, how to edit the data, how to organize it, how to make it accessible, and of course, many ethical and legal questions. And I'm sure you're seeing many such examples at this event of how we're trying to move from capturing knowledge in text into capturing knowledge visually in 3D. But in any case, at the heart of this promise will be, next slide, the AR cloud. And the thing is that whoever controls the AR cloud could control how all information is organized and accessed. So the battle for the AR cloud is on, and it will be fierce. So next slide is asking if it exists already, because many people have seen some AR cloud services, like on the next slide. And these are, some really good AR services, but they're not quite the AR cloud. If you go to the next slide, there's also some of the GPS-based services that are not really the AR cloud, because GPS by itself is not accurate enough. I mean, if you try to see in this picture, where is that restaurant, it's pretty hard to find it. And the next slide is really about the image recognition in the cloud, which is also not quite the AR cloud that we're talking about. These services, by the way, could be great precursors to the AR cloud, but they can't really do what the AR cloud can do. And the next slide has a short video kind of trying to explain what the AR cloud can really do. It really needs to understand the actual scene, the geometry of the physical environment, the objects in it. Without it, it's pretty tricky to blend virtual content with the real world in a believable way, let alone, share the actual experience with other people. So next slide, we're asking the question of how to make an AR cloud. What are the ingredients that you need for that? So next slide, first point is a scalable and shareable point cloud. Point number 2 on the next slide is an instant ubiquitous localizer. And next slide with the point number 3 is real-time and multi-user interaction. So now let's break it down point by point. Next slide is dealing with the first point, persistent point cloud. Now, point clouds are not new. There have been many proven ways to create point clouds, from things like LiDAR and drones and depth cameras or stereo cameras, photos, videos, and many other ways. But for the AR cloud, these point clouds need to be persistent, always accessible, and aligned with the real world coordinates. And of course, then it should understand the geometry and the shapes of the real world and be high resolution enough to support the things that AR needs, like occlusion and collision. Next slide. Yeah, you're already showing that video, the scalable point cloud. It should be able to scale to very large spaces and then connect multiple large spaces together. And in addition, it should allow users to contribute and continue to refresh this cloud over time using the different apps that can connect to it. And then next slide shows what Microsoft PhotoSynth has demonstrated in 2010. Actually, it was quite a bit of time ago, and they used a crowdsourced point cloud from Flickr photos. For the AR cloud, we need to do this, but we have to do it in real time, and we have to feed it through regular users using their mobile devices for 3D scanning. And by the way, traditional 3D maps will not be sufficient because a user will need to localize against that map. Means that when you pull up your mobile device or headset or any other device, it has to understand where you are in the world relative to the point cloud so that it can overlay the graphics accordingly. So next slide is about point number 2, the need for an instant ubiquitous localizer. So that capability is really not new as well, but for the AR cloud, it really has to work anywhere you go, from any angle, on any device that you may use, and that's not an easy thing to do. But the reason it has to work on multiple devices is the next slide, which is the need for real-time multi-user interaction on any device and, of course, remotely. Interaction in AR is, of course, not new. We've seen that for a couple of decades. But the AR cloud will enable or will support many users to interact in AR in real time. If you look at the next slide, there's a short video of an example outdoors. First example was more like two people trying to draw together. This is multiple people interacting outdoors with a physical object. In this case, it's something on a building, shooting game. So in many ways, if you look at the next slide, it's a lot like an MMO, a massively multiplayer game that we've seen before, where many users interact with persistent content and with each other in real time. Except in this case, and that's the next slide, it's all mapped to the real world, and it's a whole new game. In fact, it's so new and big that in the next slide, I want to talk about something that I call the big shakeup. Think about how all the big players are interacting with the web, are kind of using it as a sort of an economy to drive the web. All that could change. Just look at the next slide with all the big players, the big players, the previous slide. You can see that the battle will be fierce. The top 3 logos are the main contenders for the AR cloud, and the others are what we call the wild cards that could challenge the top players. So how do we get there? Let's first look at some of the simpler times. So next slide is really looking at the web economy. And it was really defined by what you could call clicks on links. The value of the content, the cost for advertisers was based on impressions and clicks. And that was kind of relatively easy to track and measure. But next slide is in the spatial economy, what I think will determine or will define the economy is something you could call clicks on bricks, which is really trying to capture the nature of the new world where everything is driven by digital interaction with the physical world. You know, in the early web era, companies were identified as either bricks companies or with physical presence, or clicks companies with online shopping only. Next slide is kind of reflecting more of the common strategy today, which is to really have both. You need to have of course, some online presence as well as physical presence, like we see with Amazon doing these days. But there's still a challenge to bring these two worlds together to avoid the friction. So what can bring these two worlds together? Hopefully you guessed it by now. Next slide, it's the AR cloud. So next slide is really kind of asking the question of, once you're able to synchronize information on the web and with the physical world in the same coordinate system, how valuable is that synchronization? How do you quantify the cost that we're currently paying for this gap? And what could be the upside for removing that friction? So next slide is kind of looking at what I call the attention switch. Currently, no matter where you are or what technology you use, there's an attention switch. You look at the information, and then next slide, you switch your attention to whatever task you're doing in the real world. And if it was, one time a day, that's fine. But this is something that probably happens hundreds and hundreds of times a day for anyone. So how do you kind of value that that switch? So let's move on to the next slide. There's a short video here showing that a General Electric, in the wind turbine wiring division, there's this guy that on the left, he switches his attention kind of the old way from manuals that teach him what to do to the task at hand. And the guy on the right uses smart glasses and AR overlays so that the information is overlaid on the real world. He doesn't need to switch his attention. All the information he needs is right there in front of his eyes. And you can see that the value in this case is very easy to quantify. The guy on the right has completed the job 34% faster. So that's clear time savings, it's clear cost savings, and it makes sense for any business to use these technologies. And the thing is that there are many other use cases in manufacturing, in service industry. I think, in training, probably across the board, you can see that, that value. So I think it's very safe to say that the value you gain from eliminating that attention switch is at least 20% improvement in productivity. So the next slide is looking at, so what does it really mean when you remove that friction for a whole nation? How much value can you generate when you sync the virtual and physical world for, say, 1 billion people? I think, if you take a look at the GDP associated with all these real-world tasks that require us to switch attention from information to whatever task we're doing in the real world, that could add up to a very large number. And the AR cloud, of course, could help close this gap. Next slide. And one more. And one more. So it's kind of reminded me the scene from the movie Blade Runner where the real and virtual humans kind of sync with each other. I think it's kind of a cool visual of that idea. But back to our discussion. Next slide. What about clicks on bricks? What does this do to the retail experience. So if you look at the next slide, it's one of the first examples of clicks on bricks. Was a project built by Metaio for Lego stores way back in 2010. So in this case, the kid looks at the physical product and can get crucial information for his buying decision. And it's right there on the product. How does this toy look? What does it do? How hard is it to assemble? That is very important information for the buyer or the decision maker in this case, which is the kid. But then if you look at the marketer, they can also learn a lot about the interaction of their customers, the consumers in the store with these products. They can track which boxes are mostly looked at, or which are the more popular boxes. How long are the kids interacting with them? And kind of get the whole the overall experience from how the buyer is interacting with the product. And as you can see, this is way before smart glasses and even before smartphones. All you need here is a web camera and a screen that allow you to align the virtual information with the real product. In the next slide, there is a futuristic example from the short film Hyperreality. It's a person in a supermarket, and the information is customized for your gender. It's actually funny here in this case where there's a little glitch where the system thinks the player is actually male, not female, and you see how the information on the yogurt that is trying to buy is changing. The next slide is showing another example from a product interaction, but this time at home. So this is from the short film site. And I think you can get by now the idea that on one hand, it gives valuable information to the consumer, to the user, but on the other hand, whoever made the product can collect invaluable information about how the product is being used. So when every interaction counts, when every interaction is valuable to someone, to you, maybe to a friend or an advertiser or even a competitor, how do you create an economy that can be the foundation for this new and very different world? Next slide is asking the question of what kind of marketplace can support this massive number of transactions? How do you determine the value of each action? And how can you support this complex incentive structure? So before we answer that question, on the next slide, I want to bring up the quote by cybersecurity guru Bruce Schneier, which said, "Don't make the mistake of thinking you're Facebook's customer. You're not. You are actually the product." And that's, I think, something that we all realize at some point. But in this new world where you could become the product for every interaction you make, how do you balance the situation? How do you give all sides a measurable and fair stake in this economy? Next slide is about asking, whether gamification and reputation models could support that. Well, that's probably not granular enough. There's not enough incentive in a gamification model to support this. Next slide. And one more. And do app stores support that kind of model? Well, I'm afraid that it's not even remotely close. In fact, I want to make here a bold prediction that in a world where the air cloud is predominantly used everywhere, app stores will die. So next slide, we're turning to the question of who can build it. And the following slide looks at some of the giants that are the top contenders. You have Microsoft, Google, and Apple. So next slide is kind of giving some stars to the progress of each one of those. You can see that they definitely made some progress on the hardware, the software, but there's still some major drawbacks, major things that are preventing from these players to take a leadership position in the AR cloud. And it mostly has to do with cross-platform capabilities, with the ability to run on multiple devices, and also the commitment to a persistent point cloud, which none of these are doing across devices. In the next slide, there's a growing list of startups. And I think it's going to take a crazy startup to put together the building blocks and prove the concept of this. And it's because only a startup can be audacious and crazy enough to actually demonstrate the capabilities. Yeah, I can go to the next slide. The wild cards is really a collection of really big companies that are thinking about this, that are making some moves towards it, but are still far behind. But they could always surprise us. And then the next slide is looking maybe at a whole different approach to this. What if actually it's a consortium, an open source style project that will help bring this massive endeavor together? Next slide. When could all that happen? How far are we from having a mature AR cloud? Well, I think it's obvious it's not here yet, but for the first time in history, we have the ingredients that can really bring all the pieces together. The initial demos we're seeing are real, and it seems that it's not that far off. So is it 1 year away, 5 years away, 10 years away? Let's look at how these technologies typically take to mature. So next slide is looking at a brief history of the point cloud. The first point cloud, if you can believe it or not, was invented back in the 1800s, along with photography. Of course, only 20 years ago, we saw for the first time Visual SLAM being implemented on a point cloud. And then as far as 10 years ago, was the first time that we saw a demo on a smartphone. That was groundbreaking. And then a few years later, the first AR device, the Tango, was announced. That was 5 years ago already. And we saw the SLAM, which really enables this whole AR cloud, to run with a depth sensor accessory back in 2013. And that same year, Flyby demonstrated its AR kit-like capabilities on a smartphone, which later was acquired by Apple and became the foundation for ARKit. But it took 4 years or more until this tech finally made its way into formal products by Apple and Google. So things take more time than we always want. And that's why in the next slide, I'm kind of, the previous one, sorry. I'm predicting that a mature AR cloud is probably about 3 years away. However, but the leaders in the AR cloud are being defined right now. And I think as soon as this year, we'll see early systems appear in the market, and people will really get a taste of what this can do, and it will accelerate the whole process. So next slide is what else can accelerate it. Of course, once we see depth cameras on every smartphone, like maybe on the next iPhone or other devices, I think standards could help accelerate this because it will allow the big players to collaborate. And once smart glasses become more ubiquitous and people use it all the time, that could be sort of an always-on AR and so on. So next slide, I think it's really AR cloud time at this point. And whether you're a startup, a corporation, an agency, or just a tech enthusiast, this is the time to jump in and understand what this could do. So I'd love to partner with you and to speak with everybody on this idea. So moving to the next slide and the following slide, back to the question of what kind of marketplace can support this massive number of transactions. How do you determine the value of each action? And what can support this complex incentive structure? Next slide is kind of looking at the intersection of the AR cloud with blockchain or cryptocurrency and how they could support that. Next slide, if you're new to blockchain, don't worry. I guess we all are. But for our purpose, I think all you need to know is that it's public, decentralized ledger of encrypted transactions. And here's how I think of its benefits. Click once. First of all, it's decentralized, and just like the world works. It's trusted and secure, and without it, of course, the whole concept won't work. Next point. And the other thing, it's infinitely scalable. So it's really designed to manage limitless number of microtransactions happening all over the world all the time. And last point, it supports an incentive-based marketplace, an economy that can encourage providers to join the AR cloud, help create it, and then in return can monetize its value when users consume that content. So next slide is kind of looking at who in XR, and XR, by the way, is short for AR, VR, MR. Who in XR is already doing this? And next slide is showing actually there's quite a bit of companies that have already published initiatives to support that, and I expect at least 5 more to be launching this year. First one in the next slide is High Fidelity, which is doing this for virtual reality as an in-game currency. Next is, it's smart glasses that is trying to use this to create an economy to support developers in an app store-like environment. Next slide is Lampex, which has created a blockchain for machine learning and data. And next slide is another example of the first blockchain for content distribution designed specifically to manage rights for the new emerging technologies, as well as legacy content. And next one is Render, which is an idea to distribute the rendering of all the 3D content that we need to render in this economy using blockchain across multiple machines, multiple GPU servers. And another one, next slide, is from Capacity. This is more intended for the retail market to create a marketplace for creating and sharing 3D content, which is a big money saver for many companies. And the next one is called Gazecoin, which is actually just recently completed an ICO, and it's been pretty successful so far. And this is really focused on getting people paid for looking at things. It's kind of related a little bit to the clicks on bricks idea I mentioned. So you look at different products and the advertisers pay you basically in coin for doing that. Last example is from Arcana, which recently launched a blockchain power AR cloud. And it's already raised quite a bit of money in cryptocurrency through that mechanism. The idea here is that the blockchain manages sales of digital land that then landowners can use to place virtual content on it and kind of use the whole world as the canvas for this virtual world. Next slide. And one more. So when you look at all these initiatives, I think they're all fantastic and all necessary services for the future AR cloud. Some, by the way, will probably need to consolidate into fewer services and tokens just because consumers will not be able to manage, so many different coins and so many different services. But what's really missing here in that picture? How can you leverage this economy to actually build this air cloud that I mentioned? So next slide is kind of reminding us that first ingredient in what needs to be in place to create an air cloud. And it's really the scalable, shareable point cloud. This is the hardest to build because it's so massive. I think humanity hasn't really built anything at that scale before. But a blockchain economy could help accelerate its creation. Next slide is, again, reminding us this persistent point cloud. But what if you can get millions of people to help scan the world anywhere they go and then upload it to the air cloud so that we can keep it, so we can cover more ground, we can keep it fresh. And we can also use that blockchain system to incentivize more people, and especially businesses, to contribute their content, their videos, their photos, their scans, to create an even wider coverage of the world with this point cloud. And of course, the idea is that they will all get some fraction of the token for contributing to the air cloud, and other people using it may be charged some fractions of the coin for using the cloud, and that's going to be depending on the value of the part of the cloud that they're trying to consume. So the next slide, I think this cryptocurrency approach could offer the incentive we need to build this massive air cloud. And it may sound crazy, but few companies have already started working on this. And you'll hear in the next few weeks about a few of those initiatives that are already out there with the tech in place, but now kind of creating the foundation, the open approach to supporting this concept with a blockchain-based economy. Next slide is really that idea of having an economy for clicks on bricks using that concept. So if we do it, in the next slide, it will help eliminate the attention switch. Next slide, it will help sync the virtual and the physical, and perhaps increase the GDP by 20% or more. So I hope that you realize by now that there's really no time to waste. This is really, next slide, air cloud time. And we all have to jump in now, or the air cloud will leave us behind. So again, whether you're a startup, an investor, a corporation, an agency, a developer, you're just kind of interested in this field, I think this is the time to really jump in and help build this air cloud. So with that said, we would love to talk with you guys, maybe over email or over the phone. And thank you very much for being with me today. Thank you.